Здравствуйте, дорогие зрители. Меня зовут Лариса, я продюсер Института Стрелка. Спасибо всем, кто смотрит нас в Ютубе, Фейсбуке, ВКонтакте и собирается провести с нами в ближайший час. Я бы хотела представить спикера нашей публичной программы «Стрелка 2020 Live» Холли Джинбак. Холли — географ, исследователь экологической социологии, преподаватель исследовательской программы «The Terraforming». После лекции будет сессия Q&A с Холли, так что, пожалуйста, задавайте свои вопросы в комментариях под постом трансляции на любом языке в чате в Ютубе. Мы их соберем и во время эфира передадим Холли. Также во время самой Q&A-сессии тоже задавайте свои вопросы. Лекция пройдет на английском языке с синхронным переводом на русский. Вы можете смотреть с русской дорожкой в русскоязычном Фейсбуке и ВКонтакте Института Стрелка, и на английском на странице Стрелка Институт в Фейсбуке и на Ютубе. А сейчас передаю слово Холли. Holly, here you go.
Hi, I'm so glad to be speaking with you all today. Today I'm going to talk about collaborative geoengineering, and the title of this talk is somewhat aspirational. I wanted to present some of my recent and current thinking about how to make intervening in the climate more collaborative and less technocratic or expert-driven. Now, obviously, we want a lot of experts involved with something as dramatic as intervening in the climate system, but it's also really urgent to have more people involved. Ordinary people can serve as a check on experts in a time where the systems of expertise we have are a little bit broken. Experts are caught up in politics, they've been underfunded by governments, and they're subject to an array of different incentives that pull their loyalties and work in different directions. And so one way to deal with this is to make the whole process more open, more collaborative. And so I'm going to start by talking about why the climate requires intervention, because it's not necessarily obvious. And then I'm going to speak a bit about how we might intervene and cover a range of ideas that are out there. Those first two sections are really just background to this question: how could this intervention be more collaborative? So here's where we are with climate change, and you no doubt have seen lots of graphs like this. It's an unprecedented situation. It's been a very long time since levels of CO2 in the atmosphere were this high. And so why would I say that we need to intervene? Clearly, we are intervening in a massive way, as these temperature plots show, and with disproportionate effects, the Arctic and other places warming much more rapidly. So clearly we're intervening in a massive way, and it's been terrible. So it's intuitive to say that actually we need to stop intervening, which is true in a sense. We definitely need to stop emitting so much carbon, but the situation is so out of hand that we need to even go beyond stopping the bad action and thinking about ameliorating the change by doing positive actions. So let's look at this another way in terms of the carbon budget. This is a rough approximation of what the carbon budget was in 2018 when I first started giving talks about this. And roughly each square is 1,000 is a gigaton. So that's 1 billion tons of carbon. So this is 1,000 gigatons being the carbon budget for reaching 2 degrees Celsius. Noting that the world has already warmed 1 degree Celsius above pre-industrial times. What that means is that we're going through this at 40 to 50 gigatons per year. That's the worldwide emissions. Closer to 40 if you're just looking at carbon dioxide, closer to 50 if you're looking at other greenhouse gases. So every year, 40 to 50 is taken out of that carbon budget. So that, within a decade, less now, 8 years, almost about a third of that has been spent out. Which means that this 2 degrees target is breached by the early 2040s, but this isn't an exact science, right? If we continue this rate of emissions, there may be an accounting error in this budget. So maybe there's only 700 gigatons left before that 2 degrees target was reached. And this is why a lot of nations have started to focus more, and activists especially, at, much more rapid decarbonization, because the logic of running out of this carbon budget and committing that level of warming into the system. And so for a while, people have been looking at the room for shaping the carbon budget. And this is even more present in the Paris Agreement, which talks about a balance of sources and sinks. So basically, you've probably heard about net zero targets. They assume some amount of residual or recalcitrant or continuing, lots of synonyms for this portion of emissions that is projected to continue into the future because it's so hard to decarbonize some of these sectors like shipping, aviation, steel production. Some of the heavy industry is just technically difficult to decarbonize. You know, there's a fair amount of arguments you can make about is it really difficult or not, but for the purposes of this, some amount of continued emissions is projected into the future. Usually about 10 or 20% of current emissions would continue. And so the Paris Agreement and all these net zero targets are thinking about, can we balance those remaining emissions with these negative emissions? So you'll notice this is a 2 degrees scenario, kind of the most common one. And you'll notice a couple things. The first is that temperatures with this red line, I mean, we need to stay at that 2 degree limit, we need to bend that red line of emissions right away, starting 2020 all the way down. You also notice that by the end of the century, around 2090, there's this point of net negative greenhouse gas emissions. So that means that the world is removing more carbon than it is being put in. The third thing to notice is that this green area of these negative emissions really starts right away in 2030, which means that the infrastructure and the research and the funding is getting put in place right now during the 2020s. So how do you actually go about removing these large amounts of carbon from the atmosphere? I mean, in this figure, it's showing kind of the median range of removals going between -10 and -20. So that's, you know, each of these units is a billion tons. So 10 to 20 billion tons being taken out of the atmosphere and put somewhere else. This is just such a massive project. It's hard to understand it when you look at these kind of figures. So I'm going to talk more about that. Basically, this has become a basic understanding within science, is this need for carbon removal. And part of that's because the Intergovernmental Panel on Climate Change put out this special report on 1.5 degrees Celsius a few years ago that indicates that all the pathways for limiting warming to the 1.5 degrees Celsius target with limited or no overshoot project that you would need between 100 and 1,000 gigatons of removal over this century to compensate for residual emissions and to return global warming to 1.5 following a peak. So that's interesting language because it's already suggesting that this target can be overshot, and then we could improve the situation, you know, in the future. So here are some of the ways that people are discussing removing carbon. And you see these graphics put out. One of these is from the journal Nature, the other from the journal Science. They suggest kind of a menu of options, right? Choose some of these. The common discourse is that the carbon removal portfolio would include many of these ideas. And I'll talk about a few of them in more detail. Basically, people think about 2 different categories when they're trying to organize all of these different ideas. There's biological techniques that store carbon in ecosystems, and there's geological removal techniques that use industrial processes to put the carbon underground. And so one that's been talked about a lot because it's so familiar really is afforestation. And so people who are interested in more what have been called natural climate solutions have been modeling, can we reach these goals that we have with just natural solutions, just like planting trees and focusing on soils and so forth. And so some of the the modeling from the IPCC looked at different pathways for this. And so this figure, P1, some people who really advocate for natural climate solutions are saying, we can do this P1 path, we don't need this bioenergy with carbon capture and storage or all of these industrial processes, but because we could achieve it with simply planting forests. The challenge with this graph, or kind of what it's hiding, besides the very obviously steep emissions curve, is that would require really large amounts of land. So for that kind of scenario to work, everything needs to go according to plan. And when you're thinking about converting land to forests at that scale, you have to wonder, is it really so natural? Because you need a lot of data to figure out how it's going to work, probably machine labor to help you execute it. I think this is a really fascinating option and we should pursue it, but I wouldn't feel comfortable betting that it won't necessarily happen on this short timeline that we need. Soil carbon sequestration is also a really attractive idea because the soil is such a reservoir of carbon. So, for example, in this graphic, the atmosphere is holding 800 billion tons of carbon. Plant biomass, also a lot, but soil carbon is really where a lot of the carbon has been. And a lot of that has been lost over time. So that's been a big contribution to global warming. The idea here is that you could restore that balance by putting more carbon back into the soil. There's a number of ways to do that. One of them is planting planting crops with longer roots, such as in this picture. And scientists are breeding crops that do have these longer roots, which would be one way to improve this. Regenerative agriculture looks at a bunch of different techniques that could improve soil carbon, from no-till farming being one of the main ones, but also, intercropping, a very variety of techniques that are in this kind of system of principles for how to make agriculture more regenerative and restore soil carbon. There's a lot of technical work involved with this too. This is one study that just kind of mapped out the kind of levels and layers of data you would need to execute and monitor the soil carbon. I'm just putting that up there as a reference point for how complicated. I mean, this idea sounds really simple, and in essence it is, but in another way, the execution and the monitoring and proving that the soil is there, the carbon is there, and it stays there in the soil is a big challenge. But you have kind of new startups, new organizations thinking about this. Regen Network is one. They've come up with these conceptual applications with ecological state protocols. A lot of people right now, especially in Silicon Valley, but also elsewhere, are thinking about what the data infrastructure is to make soil carbon sequestration at scale a reality. And how can they build tools that help farmers do this and guide them through it? And there's a consumer angle to this too now. There's a regenerative organic certification standard coming up, and you can find all these different products coming onto the market that aim to fight climate change and draw down carbon with their various practices that go into these products. So it's kind of an interesting area of opportunity right now, but we don't know actually what the result will be for the climate. Because one of the challenges with these natural or ecological techniques is that the ability to store that carbon plateaus after a while. So a lot of times people compared the yearly removal potential for each of these approaches. And so if you're just looking at 1 year of time, you could really store a lot of carbon by planting trees or improving soil carbon. But after 20 or 30 or some amount of years, measured in decades, those sinks are going to become filled up. You're going to have planted all the trees you can plant or put as much carbon in the soil as it can hold. And then you need to maintain that carbon there and not lose it, because if a wildfire happens or if you change the farming practices, then that carbon will be released again. So for that reason, these techniques could be kind of the first wave of carbon removal because they can be implemented relatively quickly. But for these longer time scales, you would want systems that can continually remove year after year after year well into the next century, which is where these more industrial approaches come in. And that's what I'm going to talk about now. But a key point of this is that every delay, every year, we're not doing more to curb emissions. It's using up the capacity of those natural systems in the future. So, for example, imagine that you spent a huge amount of money over the next 50 years to realize these forest and these soil plans. The amount that those could store if you're continuing to emit at this crazy rate of 50 gigatons per year, all that work would just buy 5 more years of emissions. So if you think about this, it's clear that we need to decarbonize immediately. And B, it's clear that we're going to need industrial systems that can operate for longer periods of time than the natural systems. One idea that I threw in here just because it's getting more attention again is this idea of ocean iron fertilization. So people have started thinking about ideas that don't require land because land is a scarce resource. And the idea with using the oceans to take up more carbon is that you could put in a substance, a nutrient like iron, for example, in places that are nutrient limited, which would grow a whole bunch of plankton. And then the plankton would sink to the bottom of the ocean, and that would sequester the carbon. Of course, here, the monitoring challenges are even more complex than with the soils or with the trees, because it's very hard to know what happens to the carbon after this plankton bloom has grown. You can monitor the plankton bloom very easily by just looking at it from space. But as far as the carbon flows, it's a tremendous technical challenge. So bioenergy with carbon capture and storage is another idea that has been focused on a lot because it's already what's been put into these models that made these calculations of how many negative emissions we need. And the reason that it's in the models is because it combines familiar techniques, bioenergy with carbon capture and storage. So it involves growing biomass, transporting that biomass to a factory or a plant where it can be combusted and the CO2 can be separated out. And then the CO2 needs to be transported somewhere where it will be stored underground permanently. And so the land demands for this, if potentially, could be quite huge. And scientists and activists are both concerned about this being the main focus of negative emissions for that reason, although it certainly has a big contribution. And there's a lot of interesting ideas about how to design waste to energy systems that could also remove carbon. Direct air capture is something a lot of people are looking forward to because there's pilot plants that have been built. And so basically the idea is that carbon is removed directly from the air. Then again, it still needs to be transported somewhere and stored. And so right now, this has a very large energy cost. I don't need to go through the numbers, but you can imagine that it costs a lot to power these types of processes. And that could be a limitation on this because it needs to be powered by renewable energy in order to be carbon negative. So right now, the initial plants are the carbon is being used for different things. This one in Switzerland, depicted up top, is used to grow cucumbers and tomatoes and so forth in greenhouses. A plant that's going to be built in Texas will use the carbon for something called enhanced oil recovery. And these applications for using the carbon are basically because there's not a sufficient price on carbon or a policy regime that would make it worthwhile to just put the carbon underground. For this process to be economical, the carbon needs to be sold and used for something else. So that's really something that needs to change. underpinning both the bioenergy with CCS and the direct air capture with CCS is the basic carbon capture and storage technology. And roughly to see 1 gigaton of CO2 removed, you need about 1,000 facilities of the scale that we have right now. And so to draw down 10 gigatons of CO2 by the end of the century, which is what this 1.5 or 2 degrees scenarios imagine that level, you would need 10,000 new facilities. And so right now we have about 22 operating in the world. So that's a huge amount of infrastructure. You have to imagine an infrastructure on the order of the existing fossil fuel industry, but for putting carbon back underground rather than into the atmosphere. So I think we should do this. I think it is doable, but we have to realize the amount of work involved with that, right? And I wanted to mention this prospect of carbon neutral or carbon negative oil. So the idea behind this is that CO2 is captured from either from point sources or from direct air capture machines like the ones I just showed. That CO2 could be injected into depleted oil wells to flush out more oil. So this is a process that has been done at least since the 1970s. And that's because when wells are first drilled and extracted from, it doesn't recover all of the oil. It only recovers between 5 and 40%. So oil companies can revisit those wells and do this enhanced oil recovery process with CO2 and get more out. And so there's been some ideas about how to integrate that type of oil production with CO2 storage to, in theory, store more CO2 than you would need to and use these depleted wells as storage wells for the CO2. And the reason I'm mentioning this is because it shows the kind of ideas that come up when we don't have a better plan for how to remove carbon at scale. I mean, these are the types of ideas that are profitable under capitalism when we have no plan for phasing out oil production and no regulations about it, is that you have an aspirational goal like removing carbon and stopping climate change, and it gets turned into a scheme for continuing oil production. But this is the way people are thinking about kind of extending legitimacy of fossil fuels, is by building this circular carbon economy. This is a recent conference about it held in Saudi Arabia. This is something that Saudi Aramco is interested in. So that now they have these kind of four pillars of kind of the new era of fossil fuels, right? Reducing emissions from fossil fuels, recycling CO2, capturing it and turning it into other forms, reusing it, turning it into products, and removing it using carbon capture, utilization, and storage to remove it from the atmosphere. And on one hand, I think this is a cool approach in a lot of ways. On another hand, it brings up a lot of questions, which we should discuss about whether A, whether it will work, and B, if it's the right approach. Of course, when you actually go to some of these places where CO2 enhanced oil recovery is happening, like I do, it doesn't look quite as slick as in the pictures. It just looks like continued extraction. But maybe there's another way there. I'm not ruling it out. I just want to let you know about kind of the things that are being discussed right now in the world. So the challenge of removing all that carbon has brought up this idea about solar geoengineering, which in a best case scenario would be a time limited project. You have business as usual, you have mitigation, which does some of the work. Carbon removal also does some of the work, but it takes so long to build up that infrastructure and get it committed and designed and funded, that the idea is that putting particles in the stratosphere or other forms of solar geoengineering, this is the main one, could shave the peak off of this climate change impacts. And so let's discuss that a bit more. The idea here is that cooling the Earth could happen by reflecting a fraction of incoming sunlight back into space. So that could be done by something called marine cloud brightening, which I'm not going to talk too much about here, but the idea is to increase the reflectivity of clouds to reflect that incoming sunlight, or to put particles into the atmosphere, the stratosphere in particular, that would also reflect 1 to 2% of incoming sunlight. And this is challenging to think about because the pollution we already have here in the troposphere, in the layer of the atmosphere where we breathe from, trucks and factories and so forth, we're trying to clean that up because of the terrible, terrible health impacts of air pollution. But if the pollution we're living with right now is actually masking about 0.5 degree of warming. So if we're successful in cleaning that up, then we have more global warming to deal with. So that's one way. I'm not saying it's the right way to look at this, but I just wanted to mention that. It's a lot of, well, let's talk about it more. I want to point out a lot of the challenges. I'm concerned that people will view this simply as an issue of moving the pollution from one layer of the atmosphere to another. So I want people to anticipate that kind of logic and think about how we might add more nuance and possibly contest that. But the basic idea is that, so the stratosphere is a layer of the atmosphere above the clouds. If sulfates were used to go in the stratosphere, they would stay there for 1 to 2 years and then fall to Earth. They would circulate around the globe in the atmospheric winds and eventually rain out. So this would be a global intervention. There's a lot of potential negative impacts that need to be studied, including damage to the ozone layer, interference with precipitation. It wouldn't address ocean acidification. There would be whiter skies, unknown ecosystem responses. And one I want to call attention to is something called termination shock. So if this intervention was implemented, it would pretty rapidly cool things off, which you see in the blue line in this graph. But if that program was interrupted suddenly, the warming that was being suppressed would come back very rapidly all at once, which is the orange line in this plot. And then basically you're in a worse situation than you would have been with just really bad global warming by itself because of the very rapid shock to ecosystems from changing the amount. So we want to avoid that. Looking at these worst case scenarios for solar radiation management or solar geoengineering is what's really driving my thinking about why we need collaborative geoengineering very early on in all of this. More about potential ecosystem impacts. Again, this is something that has not received very much research attention. And so I mention it in every single talk I give, just hoping that there will be more research on it. How would these particles be placed? Probably most likely with a small, not totally small, a significant number of airplanes that are specially designed to fly in the stratosphere and carry a load of aerosol precursors. What would be put up there? Potentially sulfur, because that's a more natural substance in the stratosphere because volcanoes emit that. So the chemistry is a bit better known, but potentially other substances might be a better choice because of ozone impacts. So calcite, for example. Most of the modeling that has been done has been considering sulfur. The key point, this does not return us to an earlier climate. It's not like dialing back climate change. the reason scientists are researching this is because in models, it can seem better than the worst case scenarios. If you compare a world with this solar geoengineering to a world with a worst case climate change scenario, it just seems more habitable. So that's basically the case for research, despite all these potential negative impacts. It's kind of a risk management approach. If there's a very deep risk of catastrophic climate change, you want to know if other options might be in your portfolio. That's the logic there. And so I'm interested in all of these interventions, right? And looking not just at the material infrastructure, but also the code that goes into it. I think that we can think of solar geoengineering as a program in some senses. This is an intervention that would take place over decades, and it also relies on a significant amount of code. And there's papers that are coming out, like this one here, that have been looking at what types of algorithms could meet these multiple design objectives. And so at this point, you're probably wondering, how could these dramatic interventions possibly be collaborative? They're so global in scale, they're so specialist in terms of the knowledge base. Like, how do we get to a collaborative state, right? And so I don't actually know, but I wanted to pull out 5 threads that I think we need to be working on simultaneously, and talk about each of those in the remaining time left. And the first one of these really concerns the lack of social infrastructure to talk about challenges that bridge scales. So there's this scale mismatch between the global modeling view and the scales on which people live. And a lot of times transforming the local depends on incentives and structural adjustments at national or international scales. And we can also look at how those adjustments play out in different places. But right now we have the technology to run different simulations and create visualizations. We just don't have the social institutions that can create the conversations across those scales. In some places we have representative democracy, which does create kind of a bridge, but it isn't really a place to deliberate. And so much is still done with consultants and contracts and not in conversation with people everywhere. And so Arturo Escobar's book, Designs for the Pluriverse, talks about dialogic space with a series of proposed design labs where vision making and co-design can meet. And I think this brings us to the second point about the rural and the urban. So large-scale carbon removal will largely take place in rural landscapes, in some cases for the benefit of urban residents. So there need to be these dialogic spaces that bridge the two. And I wanted to follow that by talking a bit about the role of the city in net zero planning, because this is something that already exists, and the city is a scale in which people are used to participating more, and cities organize things in more of a participatory way, relatively speaking. I think that's because organizationally, many cities have climate within a sustainability office, and that office will deal with a whole host of issues like water and waste management in more of a holistic way. And they tend to be more engaged with community members and organizations. So I think on that front, the first step is to put carbon removal into city planning for climate action, which is what San Francisco, for example, has done in its climate action framework. So they have this framework goal, 0, 80, 100 routes, which refers to zero waste, and then transport, increasing sustainable trips to 80%, and then 100% renewable energy. And then they have the roots part of it, sequestering carbon through ecosystem restoration. And I don't think they've actually gone through how to achieve that, but they at least put it into their overall framework of the goals needed. Because, you know, these cities are analyzing what their residual emissions be, or remaining emissions after they do the decarbonization they can achieve in these other sectors, like waste, transport, energy. And I mean, the numbers are there. In San Francisco's case, 12% of their emissions, they can't figure out how to eliminate. So then they necessarily need to look at this carbon removal part. And San Francisco is one of the only cities that's mentioned things like direct air capture, for example, or some of these ocean techniques in there, but it hasn't fully been explored. And so that's one scale in which I could see a dialogic space opening around that. A couple more examples. Sydney tried a citizens jury, so they randomly selected 50 people to participate and develop a vision for Sydney in 2050. And what they came up with is a lot of material around regeneration and regenerative ecosystem as a goal, talking about things like ocean permaculture and just stuff I wouldn't expect to see in any kind of city document, but opening it up to this random selection of citizens took things in that direction, which I think is really interesting. Another example, some of the pictures on the top here are from Boston, which has also done a lot of outreach in its climate action plan, both street team outreach and meetings with the 70 organizations that help develop it. And that's interesting because the state is actually taking an approach here, the state of Massachusetts. So they have a law that establishes net zero by 2050, but it lets the people have a say in the maximum allowable emissions within that law. And so they're doing a public engagement and stakeholder engagement process to decide how much residual emissions should be allowed, and by extension, how much negative emissions will be required to compensate for those. And so there's kind of bubbling up of some more collaborative approaches. These still tend to be pretty technocratic, but I think it's an opening to push for more action, which won't happen if it's just confined to cities again, because so much of the carbon removal takes place in rural areas. And many of these initiatives conceive of participation in pretty narrow ways. But it's a start. And this is why I think communities can't wait to be invited to the table. I think that people have to more strongly lead the charge here, because this gigaton scale of carbon removal will not happen with business as usual. Talking and listening to investors, they're not going to invest in these carbon removal schemes unless the policy is there first to drive it, right? So something like carbon capture and storage has existed technologically for 45 years or more, but hasn't been taken up. And so there needs to be wider cultural awareness to demand it and to support it and to pay for it and to make sure the costs of this massive infrastructure project don't fall on the most vulnerable people. So a third thing I think we need to do is develop visions of collectively owned industrial carbon removal. So it's very easy for these cities to think about, regenerative ecosystems, particularly parks within their city or whatever, but that's not anywhere near the scale that we're going to need. And so I think this intersects pretty clearly with the conversations happening about a just transition and jobs in carbon removal. So who does the work of carbon removal? Right now, there's entrepreneurs getting into it. Rural workers who are going to build it, machines, probably automation and machine labor is going to really change how it would be deployed compared to how the existing fossil fuel infrastructure was deployed during the last century. And nature, of course, is doing part of the work, but there's questions about what kind of work this is. Is it good work? Is it going to be good work, or is it going to be a burden? Right. We already know that there's this legacy of women and people of color that are expected to do the cleanup work, the care work, the ones that come in and fix and tidy up things after the men have done the damage. I mean, it sounds illogical, but I think there's data there to support it. So what kind of work this is going to be really important. I think there's also ways we can look at it as caring labor, as a gift, but it needs to be designed in the right way. I also think that this connects the just transition conversations can connect with these broader conversations about transition, to talk about design and how workers can be a part of the designs. I think we need to take this perspective of ontological design to heart. So this observation articulated by Arturo Escobar that in designing tools, objects, structures, policies, expert systems, discourses, even narratives, we're creating ways of being. So what does that mean for something like carbon removal? A way of being that is cleaning up past legacy messes and leaving the world better. You can call that regenerative or whatever you like to call it, but I think we should be focusing on that too as part of the design, what way of being is being created. And so a final way to approach this is with the conversations happening about an international Green New Deal, which really needs to center communities, workers, and local health in terms of carbon removal. I think this is really the only way to approach this massive infrastructural project, is to center what people need. And I think that that needs to find places where it can interact with how do you finance high capital industrial infrastructure. I think the international part is really important because one goal that we can work towards and one frame that should be in the discussion is the climate justice frame. So countries like the US, who have committed a lot of carbon pollution, I think have a mandate to remove that pollution. And now the technology exists to do that, to remove these legacy carbon emissions. And so that can be a political demand. Basically, to wrap up, we have these technologies that we can put to work, taking carbon out of the atmosphere where it harms everybody, including people who had no benefit from that carbon, right? And are just suffering the harm from it. And we can take it and put it underground where it's not harming everybody. So I think there's a moral obligation to try to do that. And I think that doing it collaboratively will have the best results. And failing to do it in a collaborative mode will either result in it not working or it having really bad impacts that weren't intended, but fall onto vulnerable people. So there's a lot at stake here. And I look forward to discussing it all during the Q&A. So that's back to you, Larissa.
Right. Thank you very much, Holly, for your lecture. So we got a couple of very interesting questions here. I will start with a complex one. Our current economy and value system, and more specifically, our money as cash, are priced on industrial supply and demand. Trying a metric on the value of CO2 to such a system is simply adding a layer of mass, but not reconfiguring the future. Do you see an opportunity in trying our monetary system directly with carbon budget and carbon counts? In that the more we spend, the less carbon there is? If yes, what are the challenges in bringing that concept to life?
Is there any way you could cut and paste that into the chat so I can read it? Because
no problem.
That was an amazing question and a lot to take in. Thank you. Oh yeah, that's a great point. Tying a metric on the value of CO2 to such a system is simply adding a layer of maths, but not reconfiguring the things. Yeah. I think this is a really interesting proposal, but I worry about like what happens when you tie funds and other things into flows of carbon. And part of why I worry about that is because California, for example, depends on selling these credits and so forth to fund its its climate change programs. And so when the price of oil collapsed a few weeks ago, they had less revenue available to for this. So you have to be really careful of tying these things together. I think that the way I like approaching this is to have a requirement that emitters have to take back their carbon, to have a certificate of obligation at the point of production, probably, where everybody who is emitting now has an obligation, and then that they fund that how they need to. But we should talk about all these different possibilities and have a collaborative discussion about them, I guess, is my main point. With a lot of people who have better financial expertise than I do, for sure.
Still, thank you very much for your comment. And I'll continue with also some complex questions. What is the amount of sulfur that would have to go into the atmosphere to be able to make the geoengineering scenario of 2075, 2090 working? And I'm just putting it here as well.
Oh, yeah. I don't have off the top of my head figure for that, because there's a lot of different scenarios. I mean, the modelers are running, several of them, and that's one of the main variables, is how much, if you do this many megatons versus this many, how does it respond? So it really depends on the scenario and how much of the warming they would want to be suppressed. I've heard that a popular approach is not to suppress all of the warming, but suppress a portion. But the main takeaway that I would give there is that the amounts are not prohibitive. They're a lot less than the amounts of sulfur pollution being sprayed, into the atmosphere every day from power plants and trucks. Because the injection is so high up, you don't need as much of it. I hope that makes sense. Yeah.
Thank you. Thank you, Holly. So I'm continuing with the questions. You have mentioned the red dialogue space as part of the complex political landscape. Which countries would have to collaborate to make the positive change happen? What are the plans of putting them together to achieve the collaborating action rather than just approach? I am putting it into the chat.
Thank you. Yeah, this is an interesting question when thinking about the architecture, for example, of the Paris Agreement. So that was considered to be the best we could do, is to have this somewhat decentralized things where every country makes its own commitment, and then they figure out how they're going to do that commitment. And so it is, in a lot of ways, a kind of a bottom-up approach. And so I think that countries would need to collaborate kind of on that level of committing to certain targets. And then I don't know how much more that we would need there. I think the trickiest thing has been, still is, and will continue to be technology transfer and climate funding, both for adaptation, but also potentially for carbon removal. I think that part of the carbon removal thing that we need to realize is that not the capacities are geographically unequal. So some countries have much higher capacity for CO2 storage and other countries don't. It's like a geological thing. Some countries have the ability to grow lots of biomass, others don't. So there's necessarily some amount of international exchange and collaboration there. You could think, for example, of Sweden, which has really strong goals for net zero, but doesn't necessarily have a lot of CO2 storage space. So they can ship their CO2 to Norway and have it stored under the sea and so forth. I think we'll need those kind of collaborations. And that's not necessarily what I'm talking about in terms of, public or designer collaborations. I think on that scale, it happens a lot more within, local places and national policies back and forth, dialogic spaces between those.
So that brings us to another little bit different question, but still relevant to the issue that you aroused that taken place in carbon emission removal between countries. Is it possible to, what about the possibility of international citizens collaboration in a geoengineering project? Or are they more realistic on local level?
Yeah, I think in terms of solar geoengineering, I think it would really benefit from an international collaborative effort, both obviously among scientists, but also among citizens all over the world, because only then do you really get to understand what these approaches mean for people living in different places. And so I wish desperately that some funding organization would design some, fund some kind of collaboration that takes place in multiple countries where there's dialogue, and that's in conjunction with the research that are being done. So the researchers, an international team of researchers, could model and understand things that people in different places are concerned about. I mean, that would be my dream.
Right, it truly is. And talking about the smaller scale of impact, what about what can I do? It's a question from our viewer. What can I do for the carbon emission removal if I have no relation to those in power or to scientists? So talking about just a person, what one could do to somehow impact this global shiftings?
Yeah, I think the thing to do is organize with other social movements, especially ones that are already working on climate, and help them shape their positions and their demands around carbon removal. And there's a lot of different, if you live in a country where there are NGOs and activists who are working on this, I know we can't take that for granted. But there are a lot of NGOs that are starting to think about what these net zero targets mean for their organization or for their movement. Do they support just ecological carbon removal? How do they think about CCS? And I think that the thing there is to not just vote yes or no on a technology, but to ask about what are the conditions in which this would be good, and put that level of nuance into the demands. And I think that everybody can, if you have such an organization where you live, you can get involved in its policy and make some discussions there, bring some research, and collectively educate each other and have some discussion of whether you would want to demand carbon removal and under what conditions and what particular policies you think would be effective. I think that would make a huge, huge difference, actually.
Okay, thank you. I have another complex question. I'll put it in our chat and saying it online. Could you please reflect on possible injustice among different social groups, communities, and countries imposed by geoengineering projects? Is the change that all benefits will be enjoyed by the richest while negative will be felt by the poorest?
Yeah, I think that is the default scenario unless we engage with this, unfortunately. I'm tremendously concerned about this. I think that the most likely path is that I think in terms of carbon removal, people, different nation states, for example, and companies will use the idea of carbon removal, or make kind of empty commitments to net zero goals without fleshing out what's actually needed to remove those levels of carbon. And then in 5 or 10 years, it will be revealed that we aren't on track to meet our carbon removal goals. We also aren't on track to meet our mitigation goals. And so there's been so much delay. And then the idea will be, well, now we need solar geoengineering. Maybe not in 10 years, but maybe in 20, because there hasn't been enough effort to actually remove carbon. It was just used as this kind of storyline to continue emissions and maintain investor legitimacy in the fossil fuel system. So that would be the most likely thing. And then solar geoengineering gets invoked, but the research there hasn't been done in a comprehensive way. It hasn't fully explored all of the ecological considerations that it needs to. And it's been, it comes up as this solution, which is supposed to be cheap, and we start doing it, and then there's some problem with it because the research was improper. And so I think that to get away from that worst case scenario, I didn't talk about the injustice, but it's implied there, right? There's so much. We could talk all day about the potential for injustice there. But the way to avoid that scenario is to have collaboration from all types of people right now to move carbon removal into something that can actually happen, to continue to press more strongly for phase out of fossil fuels and decarbonization, and to minimize the residual emissions, because we could end up in a situation where there's so many residual emissions and then we need so much carbon removal. So we need to minimize that. We need to fund adaptation better because there will still be some warming. And we need to make sure that the solar geoengineering research is public, transparent, open source, and looking at the right questions. So I think that collaborative geoengineering is our best hope for avoiding this worst case, very unjust scenario.
And talking about joint efforts, do you think bodies like Digital Europe, if you know such, or Internet Plus, it's a Chinese initiative by the minister, can really affect the climate change?
I don't know enough about those to comment on them.
So I wish I could invite our listener to participate in this wonderful chat. But okay, then I have a question that brings us in touch with the current situation. Have you read the article by Bruno Latour about the dress rehearsal? Shortly, it states that the way in which restrictions and policies are implemented today to stop the pandemic could be implemented to stop climate change. What do you think about this?
Well, no, I haven't read the article, but I will. It sounds like from your description that I would have some problems with it, because I'm very concerned with the ways in which, for example, simple modeling simulations were used to put in place blanket policies. I do think that this moment does open up a space for what's possible, though. And I think that one of the more interesting spaces it opens up is this conversation about what to do with the fossil fuel industry. And I think we have more possibility there for talking about a managed decline or a phase out, or even transitioning these enterprises to become carbon removal storage service enterprises. So I think if I was to think about the pandemic in conjunction with climate change, that's where I would focus on.
Thank you very much. And I think I'm going to choose the last question, though we have a lot of them, but some of them are really long and needs like a proper discussion. So could you give a couple examples showing what environmental justice is, as you mentioned it at the very end of your lecture, to understand how we could deal with it and maybe notice it and maybe do something about it?
I mean, I think there's a lot of environmental justice components that are relevant to geoengineering, both solar and carbon removal. So there's the distributive justice component. Okay, so who bears the harms and benefits of a new, project for bioenergy or direct air capture or whatever? We need to put that front and center and weigh it. There's the procedural component of who's making the decisions. There's the intergenerational component of how much responsibility are we putting on future generations with this carbon removal stuff and betting that they're just going to somehow manage to remove all the carbon, even though we didn't do the groundwork to help them get to that point. There's the recognitive dimension of understanding that people have different values and come from different cultures. I think there's a lot of environmental justice concerns, especially when you're talking about land and thinking about who owns what land, and if that land was stolen, and are you now planning to use it for removing carbon to benefit some other company? I mean, we could talk a long time about these dimensions, and I hope that we will. And I hope that a collaborative approach forces those conversations onto the table, because this technocratic way of just looking at curves forgets all that other stuff all too often.
Thank you very much, Holly. So if it would be helpful, I will give you just a link for a YouTube conversation. I just started with more complex questions. And for now, I just want to thank you and thank Sasha Baich for being our interpreter today. It was a real pleasure to spend this evening with you. So do you want to say goodbye to our listeners?
Yeah, well, I thank you for listening and caring about this topic. And please feel free to email me if you have more questions, because I know it was a lot of technical information. I'm happy to speak with any of you.
Yes, thank you very much. And I just said the last thing, that our lecture will be available on Strelka.com and on Strelka Institute YouTube all the time. So please feel free to watch it and to contact us for any further information. And also please follow our common events also on Strelka.com. Thank you, everybody, and bye.